Okay, so here is how you properly solve this problem to get the highest possible runtime. Um, I used JavaScript because I thought I'll try using a different language every challenge, because why not? And it turns out I might not quite understand JavaScript as much as I hoped. So you start off, you make your constructor for
So
your
what's
little
the other
hash map.
problem?
Well, we'll get there, Gabe. Calm down. I gotta explain the code. Y'all can see it, right?
Explain
Yes,
the problem first before the code.
I know. I don't know what the code is doing if you don't say the problem.
The problem is that it runs too fast. But if you mean the actual problem we tried to solve with it, let me pull that up real quick. Here's the problem, and me trying to fix my thing. But problem is, you're gonna make a hash map. For those of you who don't know what a hash map is, effectively, it's just a map where you have a value that's the key, and then the value that the key actually goes to. So in this case, if you put 1 in the hash map, you get out a 1. If you put a 2 in the hash map, you get out a 2. And then uh, effectively, so it's trying to make and then edit by adding objects to the hash map and removing objects from the hash map. And so there's not a great visual on the problem itself. So let's just see if we can get a better visual for hash map by just looking up images. There's a more address value. Here you go. So yes, key 1 goes to A. So this is a hash map for 1 to A, 2 goes to B, 3 goes to C. And then you could, and this problem is pretty much trying to say, okay, give me a hash map and then put in this functionality so that way I can add values. So if you wanted added 4 goes to D, you could add that. If you wanted to remove that 2 goes to B, you're supposed to add that functionality. And if you want to make it so that 1 now points to F for some reason, you're also supposed to add that functionality. So you're making a data structure called a hash map that has a get, so get this value, a put to add new values or edit values, and then a remove to remove keys and values. So that is the goal, is to make a data structure that does that. So here is my first attempt at it, where so first you make the constructor for the actual hash map itself. And so for JavaScript, this really just means like I just had a thing that says I have a map and the map is going to be an array, and then it returns itself because it's a constructor. And then my first thing was to make this search function, so that way, because I thought, oh, it'd be easy, I'll just make like a binary search thing. So as long as I have a sorted array, it'll be easy because I'll just start in the middle of the array and check if the current value is less than or equal to what I'm looking for. And if not, then it'll keep searching until it finds it. So the first thing was this current index is going to be the middle of the array. So so it's just the length of the array divided by 2, easy. Floor means it cuts off any decimal points, because since JavaScript doesn't have hard typing, I can't just put an int. It'll try to keep the decimal and convert the variable to a float. We don't want that, so I just mathed out floor to make sure it truncates anything. And then the steps. So how long each step is going to be. I want to make that half of the of what the I want to travel pretty much half of the distance I'm already gone. So I start in the middle of the array. I don't want to travel. I want to travel now a quarter of the array every time I take a step, and then I want to half that every time as well. So it starts off at a quarter of the array, and I put a seal here. So instead of truncating, it instead rounds up. So like a 2.5 would turn into a 3. And that was because you don't want your step to become 0, because if it becomes 0, this will just loop forever, because you're not actually doing anything. You're just staying in the same spot, checking the same value over and over and over again. Constant.log for debugging, best way to debug. So then it goes to a while true loop. And so pretty much it says, okay, is the current index, so the current key that we have, or does the value here equal the key? So is the current, oh, sorry, I wrote this code like a week ago. So of course, that's right. Okay, so this array is holding actually tinier arrays in it. So because like at the input they give you is like, this is the input, so this is the key, this is the value. So this array is holding a bunch of tinier arrays of each with each with 2 elements. So hold a key and a value, and we have an array of these kind of arrays. So first it checks, okay, for this, for the in the middle of the map, is the key for for the element in the center of the map, is that equal to the current key? If it is, then that means this key already has a value attached to it, so it returns the current index, so where in the map it is, and the 1 just is effectively true for meaning yes, it's in here. And then this just checks, okay, well, if the key is smaller than what it just found, then we know we should be going to the left side. So we should be going further back in the array. So we need to go to an index that's less than half. And so we just check, okay, well, are we currently in 0? And then the more I thought this was going to be very simple, but the more I kept doing it, the more edge cases I kept finding and crashing on. And so I realized, oh, I also need to check, are we currently at 0? Because if we go backwards anymore, we're getting outside of the array. And then I also had to check, are we, I believe this is current x minus 1 equals, are we like are we on the the farthest right side of the array? Because if we are, then that means the key is not in the array. Because if it's smaller than the biggest or if it's smaller than the smallest element, then that means it's not actually in the array itself, and so we should return that it's not here at all. And then after you double check all your edge cases, then you just step backwards by subtracting step from the current index, and then then you edit your step to be half of what it currently is, and then you check, all right, are we outside of are we at the edge of the array? Because if so, we need to just say it's also not in the array. If it's actually bigger, then you just do the reverse, where you double check. So now now instead of going backwards, you want to go forwards in the array. So you just step forward by adding up this, and eventually you might actually end up finding it. And if you at that point, you would actually return that you found it here. So
Nice
all
spaghetti search.
it was this is what happens when you don't just do a first draft and then forget to work on it again. So and so then the rest of this is very simple because it's literally just calling this function effectively and then doing whatever it needs to do. So they require 3 functions for you to make: a put, a get, and a remove. And so the put is just a key and a value. So put this key in the map and map it to this value. And if it already exists, overwrite the key's value with the new value we just put in. So it searches, is it in there? If it is, then it just takes the map, it splices in. This fancy splice function is what made me think of this solution. And I also think it's what's causing the runtime, because what this splice function does is it effectively takes the array, splits it in 2, and then based on what you pass into it, stitches it back together, possibly with new values. So I believe the splice takes it, like the first thing you get is the actual index that you're trying to splice around. So this would splice into whatever the first thing returned was. So if, for example, we found the key did exist at like index 10, then this would be a 10. So it's going to split the map at array 10, and then it's going to this tells it, okay, do we actually want to delete what's currently there or not? So if it's a 0, you're inserting a new thing. If it's a 1, then you are actually deleting something and replacing it with the new key value. So this is where it splits. This tells it if it should delete something or if it's replacing or inserting. And this tells you what you're actually replacing or inserting with. So that part, it's also, so I believe the way this works in the background based off the runtime and the memory is that it literally probably creates like new arrays based off what you're doing and actually searches through and does a lot of things that take a lot of time. So even though I thought this might be efficient because some things in JavaScript are surprisingly efficient, this happened to not be one of those. The get function was literally just search it, and then if it exists, sweet, return the result. Otherwise, you didn't find it, so return -1. And then the remove is very similar to this, just instead you're always deleting whatever you find. So as long as you do end up finding something, just remove it. Otherwise, there's nothing to delete, so you don't have to worry about it. And so that is the worst way to do this problem.
Yay.
Where
I'm
I know it's-
impressed by the creativity on this one, man. This is good.
Despite making a hash map, there isn't a single hash that goes into this thing.
So it's not like the hash itself is literally like because yeah, you might have heard of like hash functions or whatever, but there's no hash function for this. It's literally the hash function is whatever they want you to be. It's like a manual hashing, which is weird. I did find out, or like the way I figured to do it is just instead of doing a big old array, just make it a binary like search tree, and then that would achieve this what I was going for without having to do all these array dot splicings, which should increase the runtime like a billionfold, but I was not able to finish it in time, and that is my solution.
Well, good job, dude.
And unfortunately, it is the winning solution, as there were no other submissions.
Hey, man. That's why we need competition. I'm not, incentivized to try anything.
All right. You guys want to learn about malware?
Let's learn about some malware.
Okay. Where's the, there it is, present. Okay. Now I got to share my screen. All right. That's not what I wanted to do.
Cody says he has a last-minute JavaScript submission.
Okay. Do we want to see that one real quick?
Let hash map equals new map. Well, wait, is that the submission? I like it. It's very elegant.
Alrighty. I don't know enough about programming, so yeah. Or JavaScript. Anyway, malware. What is it? So here's what I'm going to tell you. So this is the history of malware. Going to go over what categories of malware there are, how you get them on your system. Then the three sort of categories of malware I'm going to go over from how they're organized in chronological order is first stage is like early internet. After that, there's, the internet came around, and then there's like current day. So malware can fit into a lot of different categories, not just one. So it's not like they're not mutually exclusive. Like a virus can be ransomware, and a Trojan can be adware. They're just like, you check the box if they're this or not. So a virus can, copy its own code into the program to run when that program is run, but it can't like spread to a new host. It needs the user to like move the infected program around. A worm, however, can do that on their own. They can mass email themselves. They can spread over the local network, stuff like that. They don't need a user intervention. A Trojan is something that you download off the internet. That's like, free Minecraft account generator or whatever, and then all of a sudden, all your important Minecraft documents are encrypted. That happened to me when I was like 10. Ransomware is something that restricts your access to a resource. So something like WannaCrypt, where it encrypts your files and asks for Bitcoin to get your files back. What were you saying, Liam?
Oh, I was just saying very specific.
Yeah. So spyware is stuff that watches what you're doing and sells that information to other people, or like uses a keylogger to record you putting in your password or something like that, so they can use your credentials to get into your computer. Adware is a program that displays pop-ups and stuff on your computer, and will sell like an ad space on your computer to other people to advertise their stuff. Any questions about malware categories? Moving on. So how you get infected. So there's several ways you can get infected. This is just a small subset. You can download the files that contain the worm or virus, and they'll run automatically or whenever you run it, and then you'll get infected. Same thing with installing untrusted programs. They could be a Trojan or have unsigned code in it. An email attachment like "I love you," where you download the attachment thinking it's something interesting, but it's not. It's an executable that's It's on your computer now. And just browsing websites. Malvertising allows, like clicking on advertisements or just going to your domain can make it so that you automatically download malware. Or if you go to a website and then your browser has a certain vulnerability in it, they can exploit that to get onto your system. So way back when the dinosaurs roamed the earth, there was something called ARPANET. ARPANET was originally just for like government peeps. They had their own special club of connected computers. Eventually, they let some financial institutions, or rather educational institutions, come on their exclusive club. And so that was the first instance of what we now know as the internet, just computers connected to each other. 1971, a researcher by the name of Bob Thomas had just read von Neumann's paper on self-replicating automata, basically probes that go out into space and then mine materials and create more probes to go out and do the same thing over and over again. So he wanted to create a program that could do that. So it basically copied itself via ARPANET to other computers. Didn't do anything malicious, just display the message, "I'm the creeper, catch me if you can." The first ever intrusion detection and prevention system was inspired by this, I think called Reaper, that was specifically designed to detect this piece of code on a system and remove it, keep it from spreading, and excise it from your computer. A few years after that, Wabbit. Basically, what it does is when it's run, it basically forks its own program, so it creates more child processes. It doesn't spread very well. It's kind of like a virus where it's attached to another program. You have to run that first. It makes copies of itself on other programs in your computer, as well as just other processes running. It spreads very quickly, hence Wabbit. It basically just eats out your system resources and causes a crash after all the you can't allocate more resources for the next fork. Animal and Pervade was kind of interesting. This is a malware duo where you download Animal, and it's kind of like a 20 questions game that tries to figure out what your favorite animal is. And while it does that, its partner Pervade works in the background to copy to every single directory that whatever user ran this has access to, including like shared magnetic tapes, so like physical media. It was intentionally non-harmful. It just spread itself as far as it could, didn't really do anything. And then when the OS it affected was updated, it stopped because it changed the format of the file status tables, which Pervade needed to work. And then, the developers for Animal and Pervade didn't update it because it was just a fun little coding prank. So yeah, why do I have to do that? Okay. Once the internet rolled around, a whole new attack surface opened up. So websites, email, stuff like that. So Michelangelo got a huge amount of public attention from the media. They really hyped it up and caused mass hysteria, claiming it'd be the digital apocalypse. Set to activate on March 8th of 1992. March 8th, it's happened to be the birthday of Michelangelo, the Renaissance artist. So they called it that. Not intentional on the malware developers' part, I'm sure. So basically what it does is it changes the pointer of the master boot record on your hard drive and changes the pointer to any boot sectors on physical media you might have. So that basically means your computer doesn't know, or the computer thinks that where you need to boot from is not where your actual stuff is. So it doesn't actually work. In addition to that, to make sure you can't recover your MBR, it will erase the first 100 sectors. So the media hyped it up. Fortunately, it didn't really do all that much. Although I believe Intel Exchange servers were shipped with this malware in it, which is what caused a lot of hysteria. an easy fix was just on March 7th, change the date to March 9th. And then when March 8th comes and goes, change it back, change the date correctly. That's what a lot of companies did as a quick and easy solution to avoid the payload. And that worked. I love you. This is one of the most infamous pieces of malware. It utilized social engineering to get users to click on the email attachment. That's you think it's like a text file, some professing their love for you, but it's actually a Visual Basic script that will run and then use Outlook to mass email itself to all your contacts. It's spread very, very, very quickly, affecting millions worldwide in a matter of hours. SQL Slammer. This was a rather niche. Yeah, I Love You was a pretty big deal. SQL Slammer had a pretty niche target, which was specifically SQL services. And basically opened the public's eye to how bad it really can be if you're not patched, because the vulnerability it leveraged was patched out about a year prior, but a lot of companies didn't patch their system. So somebody wrote a worm to spread to these SQL servers using this known vulnerability, and basically send itself to random IPs. Like it wouldn't even check to see. It's very lightweight. It didn't even check to see like if an IP actually had SQL available. It would just pick a random IP and send itself out. And then if it received it, it would be infected and do the same thing. This caused like a worldwide denial of service because you have millions and millions of machines all pinging each other. So nothing got done for a little while. Questions, comments so far? Alrighty. Around the current day, like 2005, 2010 onward, governments started to realize like, hey, you can do a lot of damage with malware. We should probably be using this stuff. And so they did. They now use malware and cyber attacks to conduct cyber attacks on people they don't like, foreign actors, stuff like that. Zeus. I just opened something else that wasn't supposed to be open. What is going on? Okay. Anyway, this is happening. Zeus, 2007, was sold as a malware package and framework to attack other people, often used in financial theft to like steal bank credentials and stuff like that. Spread by drive-by downloads and phishing, sending out emails and stuff. Hey, click this link. Oh, now I have your financial information. Fun. Stuxnet, very famous for allegedly being developed by US and Israel to disrupt Iran's nuclear program. It targets SCADA systems, supervisory control and data acquisition systems, connected to, I believe, their centrifuge systems to ruin the centrifuges and the uranium they were enriching. It's intended to spread by USB, so they drop a USB drive in the parking lot, they pick it up, plug it in, and there go your nukes. Still hasn't been directly attributed to the US or Israel. That's just alleged hearsay. WannaCry, probably the most infamous and most recent huge ransomware attack, allegedly conducted by North Korea utilizing a vulnerability known as Eternal Blue, which was developed by the NSA, and they kind of just held on to it. And then hacktivist group broke in and revealed it to the world, and allegedly North Korea used that to deploy ransomware to people's computers. And so don't remember the guy's name, but a malware analyst just doing it in his free time was taking a look at WannaCry and discovered that before it actually encrypts stuff, or no, after it encrypts stuff, it calls out to a URL, which is a bunch of random numbers and letters. And he thought that by doing that, he could have access to a command and control server because he thought that's what it was. It didn't exist yet, but it's probably he thought they intended to set up that as a command and control server. So basically, it would call out and give information on infected devices, and he thought he could use that to track down the people who made the virus, something like that. Unfortunately, that's not what it was. But fortunately, it basically, when it reached out with the URL and it was registered, basically it stops the spread. Like it won't send itself out to any more computers. A lot of time, ransomware, it's from what I understand, it's kind of hit or miss, because if you pay and they don't release your files back to you, then it's kind of hurting the other ransomware like community, because people think, oh, I paid for it and you didn't give it to me, I'm not going to pay for the ransomware next time. So they don't get the money they need to continue to do this. So yeah. A lot of times, from what I understand, they will release your files back to you, but they'll just come right back and encrypt it again if you don't, patch your systems. Yeah, if you have backups, you really should not be paying these people because you're just perpetuating other people getting attacked by supporting them financially. And so if you don't have backups, like the city of Pensacola, when they got attacked by this, then they paid the ransom and to get all their stuff back. So that's a WannaCry. Here's a reminder to what I just told you. Give you the information on malware, categories of malware, what they are, what they mean, how you get malware on your system, and then there's a section there I had initially, but I forgot to remove. I merged the Internet of Things and the malware sponsored by sections. Yeah, so here's my sources cited. Deno October 1st on YouTube. It's kind of like a malware museum of like old ass malware, how it works, going over the code and stuff like that. And if you're interested more in the timeline of malware, you can check out the Wikipedia article on it. And yeah, anybody have any questions?
Great job, Gabe.
That's not a question.
What was that fancy solar winds thing I kept hearing about last year?
Last year and this year is kind of an ongoing thing. SolarWinds, basically what they did is they compromised their development platform and put like a backdoor into one of their updates they're going to push out. And when they push out the update, it created a backdoor to everybody who used that software.
So that backdoor was intentional.
Not from the people at SolarWinds.
Okay.
Somebody hacked into SolarWinds.
Oh, okay. So okay, I thought that you meant like SolarWinds actually put in a backdoor that they want to use for something, but
yeah, no, they have a lot of Department of Defense contracts that would not fly. Yeah, the people who hacked in basically put in code that would create a backdoor when the program is executed, and that got pushed out to their update servers.
Yeah, I know we've talked about that one a few times in secure software. It sounded like it was pretty interesting, like what the because it was like a Russian group, right? That's the theory.
Allegedly, yes.
Yeah.
So yeah, I wanted to include that one. That one was going to be in my Internet of Things era, which was going to be like 2015 onward. But I didn't have enough content really to put there, and not enough stuff I really feel confident about. Also, didn't feel like I fit the theme of like history of malware. Like this is all pretty unique stuff, but the stuff that's happening nowadays, like in the news and stuff, besides like SolarWinds or like the FireEye compromise, I think was pretty run of the mill. So I was going to put in like the Internet of Things and like hacking tools for IoT devices and stuff like that, and talk about attack services and stuff like that. But I did not. Just cut it out. Any further questions?
Good job, Gabe.
Yeah, good job, dude.
Thank
That
you.
was a question.
Good job, Gabe. I just realized I didn't have my video on that entire time. I was doing like hand motions and stuff and keeping eye contact with the video camera. Oh well.
That's fun. Okay.